Let's talk about slats in the next minutes and how to use it with in conjunction with slat constraints and what you can achieve with these possibilities.
Some firing systems support external firing system hardware called slats or Splitterboxen. The idea of this hardware is to partition the module's electrical pins onto multiple boxes or rails that can be located at different physical launch positions, rack clusters, or racks. A single cable or wireless connection connects the controller to the module. Multiple cables extend from the module to its boxes or rails of terminals located at different physical locations. E-matches extend from the terminals to the effects being ignited. Thus, by way of using the boxes or rails of terminals, a single module can serve multiple physical locations without requiring E-matches or scab wiring to bridge between them. Depending on the firing system you use, the representation of addresses in the script file will be a little bit different. Let's have a look at a short example. I have a show with only one position here where I placed 16 shells, 12 single underscore shots and 6 cakes. Let's address this show with a fire text system that has integrated the idea of slats by default. When we address the show, you will see that the rail address in the script window is represented in two parts such as 1-2 for module 1, slat 2. If we scroll to the end of the show, you see that only one module is needed for the show. The module uses only 3 of the 4 possible slats that could be connected to the fire text system. Let's address the show again with an XPLA system. If you use Splitterboxen here, the system is using predefined areas on a module. In our case, the pins 1 to 20 belong to slat 1, the pins 21 to 40 to the second slat or splitter box, and pins 41 to 60 belongs to splitter box 3. If we have a look here, now the different Splitterboxen are represented with an A for the slat 1. B for splitter box 2. If you have a closer look at the pins at slats with the B section, you see that the channel or pin numbers 1 to 14 are used, not the corresponding numbers on the module 21 till 34. But don't be afraid, Finale will take care about that as soon as you export the firing system script. So, go to File, then select Export and choose Export Firing Script Files. Finale is now doing some checkings and present the result in a dialog. If there are no errors like in our case, you can click Continue to go on. Then you are asked for a file name. Please use a meaningful name here and click OK. The script will now be generated and it is shown in a new Explorer window, so you can open it from here, if that is possible. If the suffix of the file is not known by the operation system, there is a fine trick that Finale offers to check the content of such files. Please open the File menu again. This time choose Tools, and then open Firing System Script as generic table. Select the script file we just created. You will see a readable representation of the file, and it is enough to check the modules and channel numbers, that are called box number here. We see that all our addresses are converted into the right channel numbers for the system, because channels greater than 20 are used. But now it is time to use more advantages of the Finale addressing possibilities. Without using them, you maybe came up with a setup that looks like the following. You see that the two slats A and B are connected to the module number 1 here. Each of these slats has some cues for single shots, cakes or shells. With the use of slat constraints we can improve that and make the setup more comfortable and cleaner. Let's open the dialog for the addressing again and look at the constraint section. You see that there is also the possibility to specify what kind of effects should be wired to the slats. So let's try type as a constraint here and see what happen if we address the show. Now you see that 3 slats are used. All 3 slats are again connected with Module 1 here. This is only a demo to show you how slats could be assigned to effect groups like in our example type of effects. But if you look at the possibilities, you see that a lot of other things are possible, like the mapping of slats to racks, rack clusters, or different rack types. I will show you some other examples in some other videos later. I will also show you how to place slats on different positions. But before we end this session, I like to show you a common error that will lead to more modules instead of more slats. When you define the constraint action, please avoid to have the same constraint for the modules and slats, because in this case the complete assignments will be done on the level for modules. If we also specify type here, there will be a module for every type. Modules that handle only one type cannot divide it to different slats handling different types, because there is already only one type assigned to a module. To prove it, we made the same settings for modules and slats and do the addressing again. Then we switch to our rack layout. We see that now 3 modules are needed instead of 1, and each module has only 1 slat. So please remember that, when you use constraints for slats, they should never have the same settings as the module constraints.